Hello there, Adam. Good to see someone finally showed up. Usually, you just wait about 10 minutes for anyone who's gonna show up to come, and then we're gonna start. And while I put some music on. So, hey, nice. I need to see that when you're done. Or we need to have a sit down, actually. Okay, so let's set up everything here for the coming 3 minutes. Recap what we did last time, what I did on my spare time, and then we start. Nope, not that. Where is it? Oh yeah, there it is. That's the one. Nice. Nothing can work in here yet. These are just automated parts that I got uh, from. Like, I didn't simulate anything, I didn't move anything from its place. Oh, you meant the orientation? Okay. This is just me putting all the stuff in there until I simulate the weight, so I can know what's the width and length and like the dimensions of the femur and tibia and the leg parts. But after that, there are in the actual robot there are gonna be 2 layers of this base. So the camera and the lidar are gonna be on the top here, and all the electrical components, including the motors and stuff like that, are gonna be inside. Like there's gonna be another layer here at the bottom with all the electrical components, and these motors are gonna be inside the actual robot, not at the top like that. So this is just for adding weight until we figure things out. Like this is not even the actual battery, this is just a box, and I input the weight manually because I cannot find the battery that we need. Last, I believe the stream before the last one, I did Google it and I showed what battery we are gonna use. I just can't find it on GrabCAD, and I can't get bothered to find it anywhere, so I made its dimensions and I made the weight manually. That's all I need for now. As well as this one. So this is the Jetson Nano, NVIDIA Jetson Nano. As you can see, it's even here. I don't know if you can see that sign. This is like a graduation cap. So this is for educational purposes only. That's why it has no color. I cannot click it. Like if I try to mate it, let's see if I can try to mate anything. It's not clickable. Like the entire Jetson Nano thing is not clickable. If I click, it will just click below it, or it will treat it as if it's not there. So we're just putting stuff as makeshift because this is like the preliminary design. We just need to know with this weight, let's say all of that gets to 3 or 5 kilograms. I just want the 5 kilograms to be there so that I know when I simulate, I'd know what kind of LEDs I'm gonna be using, the dimensions of everything, and the placement of everything. So for example, this is not gonna be the finalized placing of the servos, because for example, let me show you something. If I try to move this, so this is gonna be the LEDs moving side to side. If I try to move this, let's say it goes all the way up here. We don't want it to touch. So let's say that's the furthest it can go this way. If this LED is already somewhere here, still not touching, great, okay. So let's say this is the orientation I'm at right now. The rest of the LED here and here are actually gonna collide. So I'm gonna rearrange everything. This is just, as I said, a preliminary design to get the weights of everything. But this is not the end product, of course. There is a lot to do. But hey, we're here to have fun, right? And to finish the project, of course. But first and foremost, have fun. That's all that matters to me, to be honest. Anyway, so since it's 9:12 now, let's start. Yeah, pain. I know. But let's start and see what we have in store for today. So last time, all of this wasn't here. The brackets for the servos, which is the housing of the servo, we just tested it on this one, and we had this attached to it to see if it fits or not and all that. So in my spare time, I added the brackets to each one, and then I added the C bracket here to each servo. That's all I did. As well as, yeah, I opened up a space here for the cables to come out of. So when we actually try to inject this servo inside the housing, it wouldn't be annoying. So I opened up space for it. I fixed this, the hose for the servo to be aligned with this, with the housing. So yeah, that's all I did in my spare time. But to continue the stream, we're gonna try to connect these brackets to these servos, and then to the what's it called, femur? That's the femur, right? I believe so, yeah. Let me see where it is. Yep, it's the femur. Yeah. Okay, so let's add another servo. We're gonna do this only for one leg and see how everything goes. Okay, let me raise the audio a bit. Is it because of the music or because of the audio itself? Okay, is that better? No? Yes? I don't know. Wow. Oh, you can't hear the music in the first place. Okay, that sucks. Let me fix that as well. Oh, don't fall. Okay. This should be a little bit better, I believe. If I do any more than that, I'm gonna have to yell. Cool. Okay, so I'm gonna do my best to keep the voices in check. But other than that, let's get started. We want to add another, where is it? Servo. Yep, there it is. So we want to add for it another bracket, actually, yeah, just a bracket right away. So let's take that, space it here. We're gonna have to make, I understand that all of that is gonna be screwed onto each other, so I'm gonna have to make holes for screws, but for now, just for the sake of it, we're gonna mate it right away. So let's mate this to this. Nope. Stop it. Okay. And I want to mate this to this. Yep. Thank you. With a distance of... what should be the distance? Let's say... 10? Nope, that's... huh. Let's say 6... centimeters. Let's see how that. Nope. Let's have it to be 4. Still nope. 4.5. I don't want it to be too low. Yeah, 4.5 is perfect. Okay. Alright. Nice. What else? What else can we make? Alright, so I need this. Where is it? Yep, I need this to be in line with. Where is this one? It's a C bracket. It's, I believe that's number 1. Yep, that. I need this to be in line with this. Thank you. Come on. Alright. Nice. Okay. That's actually perfect. Instead of... Let's go out of this. Instead of this mate, that distance mate, let's do this. Let's make this dude with this. Hehe. Yeah. Okay. Nice. So when this moves, this moves. And now let's have this. Oh god, everything is starting to be slow already. Because I have my OBS on to record and live stream, and then I have Solidworks on, and I have all these parts in Solidworks already making it slow, so yay me, right? We're gonna make that. And that's a laptop, it's not a freaking PC, so... Okay. Come on. You can do it. Come on. Do I need this to be... Yeah, I believe so. I think I'm just gonna make this to this. I need this to be bigger. Yep. Or, actually, yeah, I need it to be bigger. I'm not gonna arrange this one because this should have this. So, let's make this. Oh god, it's so slow! God damn it. This is gonna be concentric with this. Why tangent? I need it to be... Oh yeah, okay, never mind. I'm just not gonna use this space. I'm gonna use this instead. Concentric. Thank you. Where is it? Okay. So this needs to be... Where? There. I need that to be here. Cool. Now I need all of this to be inside. So I'm gonna have to have that face with this. Not that way. How about this? Thank you. Okay. So, here's the gist of it. If this moves, let's see here. If this moves, so this servo, the first one, we'll move it right to left. And then this one, connected here, connected to this bracket, will help this femur go up and down. We're gonna fix the dimensions later, because this is gonna take a while to actually figure out the actual dimensions. But for now, this is the point. Like, this is the gist of it, indeed. Okay, now let's add another servo. Where is it? Where is it? Where is it? Where is it? Too many stuff. And it's gonna only get worse. It's not gonna get better. Let's add... Yep. Ah, come on. Yep. There we go. Alright. I need this one to be here. Thank you. Thanks. With that to be here, just like your brother over there. And this one to be here, but the other way around. Thank you. Okay. So this one needs to be put with the tibia now. So we're gonna add the tibia. Where is it? Insert tibia. Tibia. Thanks. Please move aside. Thank you. And mate. Nope. And again, mate. With that. Okay. Again, dimensions will have to be readjusted. But for now, let's have it like that. This is gonna have to be bigger. Yep, this is the one that's gonna have to be bigger, yeah. Okay, but you get the point that now this will be standing like this, and this will be down here. Hey, hey, hey! Our first kind of clean view of what's gonna happen. Nice. Now we just need to do this 6 more times. I mean, easy, right? I'm not gonna do it right now. I'm gonna fix the dimensions first. Let's have this to be a little bit smaller. So how small can this grow? Let's look at it from here. Where do I want that? Okay. Oi. I want that to be... Yeah, can I look at it from... Nope, I don't want to mate. Can I look at it from here? And can I measure? Okay, I can get it to be from here to here. Okay. Please work. Thank you. from here to here. Okay, I need the DZ, so I can get it to be 0.22 centimeters less. So let's open this part. All right. I need that to be wider. So let's edit that sketch. Not that sketch. Where is it? Let's edit. Is it that? Yeah, it is that. Edit. Okay. Guess I'm gonna have to edit the feature. Okay. So that's what's that in wait, I need it to be 0.22 centimeters less. So that is 4.5 minus 0.22 centimeters. Cool. Okay. Now let's go and check out what happened here. Alright, that's actually better. Femur 121 has rebuild error. Okay. Thanks. Cool. Well, as we can see, it fits. Yep, that actually looks great. It might have to get a little bit, like just a little tiny bit shaved here. But other than that, this so far looks great. So let's go back to the part and see why it won't rebuild. Oh yeah, because of the extrude here. Now let's go edit that. Cool. That fixed it. Let's go see if this got fixed. Nice. Let's go. Now let's go make the tibia bigger. Tibia. Where do we wanna work? Work it. Okay, I believe that's that. So we're gonna edit the feature as well. Okay, so how much do we want to make it bigger? So it's exactly almost as big as the femur. So we want it to be outside of its So I made it 5 centimeters. I made it 5 millimeters thick this way, 5 millimeters thick that way. So that's 1 centimeter. So I want this to be 1 centimeter higher, like that, I think. Okay, of course the cutter extrude is not great. Okay. Now let's rebuild that. Okay, where's the center of all that? Come on. Are you kidding me? Trying to get a point. And you. Finally. Let's have that be... What was it? 0. Wait. 0.02. Yeah. Actually, yeah. Nah. 0.015. Oh. Yep. Better. Yeah. Nice. Let's save that and go see what happened to this. Aw, come on. This should have been a lot bigger. And where the heck is the rest of it? What the heck and heck? Okay, we gotta fix that. Oh, I totally missed that happened. My bad. My bad. My bad. First off, I'm gonna increase this. And that plane is not gonna be from here to here, it's gonna be from this face. Okay, let's actually remove the entire plane. Create reference plane. I want it to be the mid between those two. And now I want you to mirror on this, and I want you to mirror that and that. Right? Right. Okay. Much better. Now let's go edit that. Are you kidding me? Then why are you like this? Okay, let's do that. Just remove it entirely. And clear that, and extrude cut. Through all. An entity with unsuitable geometry. Are you kidding me? Okay, remove the entire thing. Let's work on that. Extrude cut. That face. Yeah. Let's go. Nope. I want... Come on. I want the one inside there. Which is from here to here. Yeah. We did say 0.015, so let's make it 0.01. Yeah. Sure, why not? Let's do this. 0.005. Hehe. Nice. These through all. Hoi. Nice. Let's save that and go and see what happened here. Nice. Let's go. Okay, in that, we're gonna remove one of the mates, which is this, and remade it to be this and that. Much better. Yeah. Nice. Okay. So, this is how it should look if it's standing up. That's long. In proportion, that's a lot longer than that. But, hey. It might do something like that as well. So we need it to be that long. So if we're looking from this angle, and just in case it has to go flat like that, that's exactly what we need. So you see that? This has to be higher than this. Actually, I might have to shorten that. So if I shorten this, this goes down a lot. so it can touch even like below this. You see what I mean here? I was gonna draw a straight line to show you, but never mind. You read the point. Like, I need this to be, let's say that this is the floor. I need this to be touching the floor first instead of the belly of the robot. So we might have to make this shorter. But for now, let's just keep it as it is. And yeah. Okay. Huh. What else? What else? What else? Oh yeah, the thing that I was showing you guys earlier, when this goes this way to its max position, here, it will hit that ledge. If this ledge even tries to go to its max position this way at the same time, for any reason, I don't know why they might have to do that, but for any reason, this is gonna be a problem. And this is not even me putting the other bracket, like I didn't even put this bracket here yet. So they are gonna collide in that case, 100%. So this will have to be fixed. For now, let's just keep it as it is. And drag that back. Okay. It's gonna look like a proper spider with time. But that's the grind, right? That's literally it. To keep trying these things and keep checking out more stuff. So we don't need that, actually. What else do we want to do? I forgot. Oh yeah. Let's fix... actually, I want to do all parts first. So let's add... Like, let's do this. This. Nope. Where is it? I think it's that. And where is it? I don't know if this will work, but let's do this. So a femur and this, that, and the tibia all copied and pasted here. Yeah. Do they have their mates? They do. Great. Let's do this 3 more times. Yep. Yeah, it's a bit clunky, but we're gonna just do that. Okay, let's start mating. Hey, no, not like that. Not like that. Okay, chill. Not like that. I meant to mate the parts in Solidworks. Good God, working this is gonna have me arrested. Huh? Okay. Weird. Anyway. It's so freaking weird. Yeah. Let's go. Where? Oh god. Um, what's that? I don't need femurs. I only need sea brackets. Okay. This sea bracket. Okay. So we're dealing with the right side of that with okay this right side with front. Okay. And then that right side of that with the front of that. Great. Okay, next. This C bracket. Oh god, no. I want this. C bracket 10. Right side. With C bracket 3. It's supposed to be right. Nope. With the front. Thank you. And then right side of that. With C bracket 10. Front. Okay. Oh god, no. What did I do? Wait. I want to fix this first. Because I want to have at least one side that's perfect. This edit feature. Can I have them flip? Okay, but I wanna flip them. Nah. Nah, please, nah. Okay. Why? This. Yes. I need it to look the other way. Come on, how do I do that? It's supposed to be like that. How? 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 Just how? Huh? What? Okay. Let's see this mate then. Where is it? Yep, that mate. If we to this. Come on. Okay. Yep. That should fix it. Thank you. Thank you. Now stop being an idiot. God damn, you had me scared for a sec. Okay. What were we doing? Oh yeah, these. Good God, man. What's that? 4 and 8. Okay. 4. Where's 4? C bracket 4. Front with C bracket 8. C bracket. Come on. 8. There it is. Okay. This? Nice. Okay. Now. Front and right. Nice. Okay. We got this. We got this. Okay. Okay. Huh. This feels exhausting, by the way. Just saying. One wrong move and all of that is gone. 5 and 11. 5 and 11. Nope, that's a beamer. Get back here. Chrissy, wake up. Okay. That. Right side. 2. That's front. Nice. And then that right to that's front. Okay. Not too bad. Not too bad. Okay, get down. Thank you. Last lead. Last lead. 6 and 9. Where are you at? C bracket 9. And then C bracket 6. This front to this right. And then this front to this right. Thanks. Wait. Can you stop? Thank you. Okay. Freaking finally. Hey, we're getting somewhere. Kind of. Let me actually do this. Nope. Let me check this out. I need an isometric. Trimetric? Yep. I'm gonna just screenshot that for a bit. Okay. Alright, so this is basically how it should look like, kind of. But in a very, this is just very, very rough. As you can see, everything is clipping through each other. So all of this is gonna be shaved, like this entire place is gonna be shaved, as well as that place, as well as that, the ends. As well as these are gonna be separated more apart, so this entire thing is gonna get longer. But for now, as I said, so far we're looking good. What else? Not really sure what to start with. So basically, we can start simulating, kind of. We can make everything defined and then start simulating. But to make every single part of this fully defined is gonna be kinda hectic. So let me see what else can happen here. So what do we have? We have a mate here, doing this and this. Then we have a mate here. So how can this move? It can move sideways. Okay. Can it move upwards? Nope. It can only move sideways. Okay. Let's have that. Mated with that. Okay. So that's fully defined. Nope, never mind. It's interfering with some stuff. What is it interfering with? This mate is overdefining the assembly. Huh? Okay. But if I don't do that, mate, it's gonna move. So let's say we delete this mate. Now, this can move. Well, we can actually not do that, mate. Um, what else? This can stay as it is. All of that can stay as they are. If I try to simulate just like that, everything's gonna collapse. Or not collapse, it's just not gonna be working well or give accurate data. So we can do this. Where did I go to start simulating some weights? Okay, first we need to make sure that this oh yeah, simulation. Cool. New study. Wait. This might make everything burn out on me. So we're gonna save and hope for the best. Okay, let's go back to model. Save. Okay, everything's saved. Okay, so where do we want to fix this thing? Okay, fixtures. Nope, not that visor, thank you. Fixed geometry. Okay. Actually, in real life, this is gonna be standing on those. So, let's fix it there and see how this goes. I know it's not fixed. Like, I know that the entire thing is not fixed on the floor actually. But just bear with me. I'm testing some stuff here. What's up, Farid? We're kinda simulating something. It's gonna be so bad and everything is already moving very slow. So just bear with me. External load, it's gonna be force. Let's say this entire thing is 5 kilograms. That's applied here. Let's say, actually, one sec. Not sure which one I should go with, but let's go with force. Let's keep it simple. Applied here. Yep, SI. Let's do 5. Yeah, it kinda does look good, but as you can see, a lot of stuff are clipping through each other All of that's gonna get fixed, but so far this is how everything should look. This is gonna get shorter. The femur is gonna be shorter, but this is how everything should look. Fixing everything to be um, like fully defined, as in mate everything, is gonna take a lot of time. So we're just gonna kind of see what happens if we try to do this without much fixtures. Okay, let's try to mesh at let's try to mesh at 4. Oh, okay. Thickness is not defined for one or more shells. Great. Actually, it's not gonna mesh at 4 because it's not gonna be able to mesh this. Which is the problem? Let's see. Thickness is not defined for one or more shells. Well, if this doesn't work, I'm gonna try one more thing. So 0.5 centimeter, which is the thickness. Okay. I don't think this is gonna work like that, so let me try something else then. Where was it? Here it is. What's that? So that's gonna be C bracket 7 plus this plus this and this and this. So these are the things that I need. This, that. Yeah, form new subassembly. That's exactly what I was looking for. Ah, I'm glad it's there, because I wasn't sure that this could be done. So yeah, this I need to open that subassembly. And then we're gonna simulate that. Let's see if the mesh works right away, just so we don't waste time. Okay, it does. So we are able to simulate on this alone. Okay, never mind, failed. uh, it's the servo. Okay, both servos failed. Refining of the mesh. I know why they failed. Yeah. Trying to know why they failed. Because you see, I meshed on 2 centimeters, and then we have these. So these. It's trying to put 2 centimeter triangles in here, but it can't. As well as these, it won't be able to do that. So, for now, what we did, let's just see here. Fixtures, fixed geometry. It's supposed to be fixed here, because that's what's touching the floor. What else? What was I gonna do? External loads, yeah. Where external loads, force. It's on this. Select direction. Want to see it though. Why won't you show it to me? Weird. Oh, because I didn't click my dumbass. It's the inverse direction of, let's say, 5 divided by 6. Let's say each one will handle 3 newtons. Each one will handle, let's say, 2 newtons. 2 by 6 is 12. Yeah, the entire thing is gonna handle 12. Or in some cases, because let's say that this spider is walking, right? So only 3 of its legs is gonna be touching the ground at a time. Let's say there is one of the patterns that will have 3 legs off the floor and 3 touching the floor at a time. So we need the entire thing to be held on 3 legs. So let's say 10 divided by 3, that's 3.333, yep. Let's say 3 newtons. What else? What else? Don't think there's anything else. Here. Well, that stopped my camera. Whoa. What is going on? Nope. Yeah, way better. What happened there? No idea. Anyway. Okay. So we meshed. Create mesh and run. And let's see what happens. It's not gonna be great until we solve a couple of issues. I'm gonna have to remove the servos from the mesh. Yeah. Yep. So let's suppress that. Whoa. Why you do me like that? Where is the wrist? Brother. What are you doing? Hello? It's not suppressed. These are the ones. Okay. Let's just suppress that. And that. Okay, now mesh and run. Material is not defined for. Oh, yep, the material itself. God damn it. Oh yeah, that reminds me, by the way. Here, let me show you something. Where is it? Okay, so we're gonna be using PLA, right? Now this, I don't know why it opened in Paint. That's weird. Let me open it in something else. Okay, let me show you guys this. How can I show it? Add image source. Nope. Yeah, that. Why won't it show? It's not showing. Huh, okay. Give me a few moments to figure this out. Okay. For now, we're gonna have to work with this. So anyway, we're using PLA. So I got the data sheet for PLA. So we can actually just go here, for example. We're gonna go where? So we're gonna go here and tell this entire thing to make it out of field, so change material. This is what we're gonna do right now. This, nope, not the base. What else? The base. The bracket. The servo bracket as well. Tibia and the femur. So all of them, we're gonna make material. Where is the material one? Yep, material. Let's just add the femur. Yep, thank you. Material. Edit material. Custom material. So PLA is a kind of plastic, so we're just gonna add new material. Call it PLA. It's not already in here. Is it? Oh, ABS is in here. Huh. So PLA must be in here. I genuinely cannot see. Where is it? PVC, PVC. Yeah, it's already... I'm in plastic right now. Anyway, PLA and ABS are kind of the same thing, so we're just gonna use ABS. I also have its data sheet right here. So, there. I also have this data sheet for ABS if needed, if we're gonna 3D print out of it. So, let's just apply ABS for everything. And there is... You mean the plastic I made? Or the plastic, this PVC plasticide? Because this plastic I made this one. This isn't the custom materials that I made, so that's why I just went for ABS. You have changed custom materials. They want to save. Nope. Oh god, that's too bright. Good god, man. Ew. Anyway. That works. Yeah, ABS is very close. It just looks horrible. But anyway, yeah, so since we switched to that, let's go back here. It should fix everything now for the simulation because we added the material. So go ahead, mesh and run, my friend. Oh yeah. This is gonna fall from over there. Israeli solver stop, numerical difficulties, pre-condition failed. Please check model boundaries, conditions, no results saved. Yep. Assembly 1 failed. Yeah. I know, because I didn't fix everything in place. So if, realistically, what's it telling us here is, and I'm not really sure why my camera is not on anymore. Give me a sec. Yeah, way better. Okay, so basically what it's telling us is this. If I apply pressure here, so let's do this. Yep, okay. So if I apply pressure here in real life, come on, you can do it. Thank you. If I apply pressure here and this is fixed to the ground, I didn't tell it that this is gonna have any. So we have a servo here that's actually holding it in real life. But here to him, if he applies pressure like that, it's just gonna fall apart. So if you go here, if I apply pressure, it's not doing what I want it to do. But anyway, this is not basically. Let's look at it from this angle. Yep. If I apply pressure here, this entire thing will collapse. So this will close on and of itself here. That's what it's trying to tell us, because it's not fully defined. As you can see, the dashes in here mean that it's not fully defined. So I have to fully define it first and then tell it to simulate. Okay, so let's make a couple of things more. Let's have this like that. Just for example. Okay. I don't know what else it wants, to be honest, because mating this and this and having it concentric here should do the trick. So if we go back here, see, now this is made it like that. See, it's not going down or up anymore. See, it can only go sideways. So this should be to itself only as a sub-assembly. It should be fully defined. But I'm not really sure what's going on regarding this. Save, enter inside the assembly, save it in specific path. Nope, save inside the assembly. If anything happens, we can just fix it again with no issues. So for this one, see, it does the movement that it should do, but this, it's not doing it because I fixed it with the last mate that I just did. So I'm not really sure what's going on. I'm gonna have to look further into this, but for now, I believe that's great progress, what we just did. So inserting everything, actually we can add one more thing before I finish the stream. A couple of things actually. As I said, this, if we look at it from this angle, let's move that aside. If we look at the entire thing from this angle, so the reason I say that this should be shorter, which is the femur, in case this happens. Okay, you go up, you come down. In case the spider needs to stand like this, I need this to be touching the floor first instead of the belly of the spider. So in order for this to be, it's almost touching the floor, but this is going to be scraping the floor as well. I need the entire spider to be held on the legs. I don't want the belly of the spider to be touching the floor at all. So in order to do that, I'm going to have to shorten this part. So all of that will get a little bit shorter. If that happens, this entire thing will, the center of this will go down a little bit, so this entire thing will go down as well. So that will fix our problem. As well as I need to fix another dimension, which is this. Because this is suspended in air right now, as you can see. just suspended in air. As well as we're gonna fix all of that, of course, like this is clipping through this, I realize that. This is all gonna get fixed later, but for now we need to fix these two things. So make this shorter and make this a little bit shorter as well. So let's go do those. First, let's do this. So apparently 0.5 was right. Let's go see how that affected this. Yeah, the angle of the leg. Huh, okay. So 0.06 is too far, 0.05 is too short. Let's do 0.055. Come on. Yeah, much better. Much better. Still clipping through, I can see it, but it's much better. Like getting this very accurately will take time to measure all of this here, measure all of this here, and measure the actual dimensions of this. But so far everything's going great, so no need to sweat it. Now let's make this shorter. Or actually, while we're on that part, let's fix the angle. Increase the angle, which is this one. So let's actually see something first. Let's... Oh god. No! The horror. The horror. Okay. So let's see what happens if we have this to be stand like that and this to be stand like that. Yikes. So I just want to see the position if the entire thing is flat. Okay. Stop freaking out, please. Huh. Okay. Yeah. The angle does need to be fixed. Because in order for this entire thing to be flat on the ground, this lid will have to look up more than it should. So if it's something like that, this will have to look... So this is the spider flat on its belly with this angle. I'll increase it a little bit. Yeah, sure. Let's go do that. Nope. Perfect. Oh no. Thanks. Don't mess up my andros again, please. Okay. Um, this is what I was talking about, the andros. This one. When I was trying to make smart dimensions for it, and I did 0.15, it just went straight, as you can see. But since you're here, let me show you something. Actually discard everything. Forget everything you know. See this? Once it loads. So once if the spider is on its flat position, which is flat on the ground on its belly, this is gonna be flat, this is gonna be flat, and this is the old tip that I have. I didn't increase the angle yet. If the entire thing is flat on the ground, this is gonna be touching the floor like that, in that position. So, do you think the angle should be more to the inside or to the outside? I think you meant going outside a little bit more, but I'm not really sure. So, let me know. Yeah, more to the outside, right? So if it's on the outside a little bit, this will go down. Like this will do this. This is on the outside here. on this place, something like that. Yep. Okay. Nope. Just as it is. Thank you. Huh? Still not fixed. What? I don't get it. Okay. That's weird. Oh, I get it. Okay. Hi. The design is coming together so well. I'm genuinely so proud of what's coming to be. Hey, thanks. It's gonna be great. Don't worry about a thing. Everything's gonna be great. Vision has a warning which may cause subsequent features to fail. Would you like to repair? Just continue. I'm gonna fix them one by one. Okay. Huh. Okay. But this should be fine. The stretch contains the dimension related to mobile. Okay. Why is this an issue? Uh-huh. Okay. One down, one to go. Two to go. Let's check out what's around here. I genuinely don't see it. I don't see what's wrong. Oh, there it is. Trim. This and that. Okay. Trim. Fixed. And next. Yeah, boy. Okay. What? Couldn't find face or plane. Um, let's edit that. Edit sketch plane. So take that plane, and now you're fixed. Great. Thank you. This is how it should be now. Perfect. Just perfect. Perfecto. Way better. Much better. Now, that's it if it ever... Nope, not that. Not that either. That's how it should look like if it ever decides to stand up. I'm still gonna make this a little bit shorter. Oi! Ah, just adjusting my seating. Okay. Last thing to do before we end it here. We're going for... Did we save that? Yep, we saved that. Last thing is to make these shorter. Where are we gonna do that? I think that? Yep. Instead of 0.2, let's make it 0.17. Something like that. I don't want to make it too short though. Okay. Gotta fix those. Where are those from? Boss extrude. Oh, 0.17. Nice. Okay. Let's go check it out. Hopefully it doesn't mess with everything else in here. And it didn't. Great. Yep, we still good. Yeah. Let's put them side by side. Side by side. Nice. Cool. So, for now, this is everything that we're gonna do in this stream since we've been streaming for 2 hours anyways. And yeah, today's stream was a little bit tiring, but we made a lot of progress. The only thing that we need now is to fix the simulations, to fix the mesh and the stuff to see how it simulates, to basically make everything, literally everything, so it can simulate well. This is gonna take a little bit of time to figure out and to remember how to do it because I forgot a lot of Solidworks features, as I said before. But for now, it's been great, and we're almost done with the entire thing. As you can see, just a little bit tweaks here and there, then onto the simulation, then onto actually printing the first leg. And this also will be recorded. I'll take a video of the entire thing when it's built and progress, not just SolidWorks. I'm gonna record all of it, so don't worry guys, I'm not gonna leave you in the dark regarding this project. And Thanks for tuning in. Thanks Adham for coming here at the beginning, and see you guys next time. So, goodbye.